Charging by contact. Charging by contact occurs when a neutral object comes into contact with a charged object. The charged object will share its charge with the neutral object. This works differently if the original charge is negative, or if it's positive. So let's imagine first a negative object. So here is some sort of material, and maybe by charging by friction or some other way, it's ended up with all these extra negative charges. Currently it has 5 protons and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Excuse me, 11 electrons, or a charge of -6. And it's going to come in contact with this object, which is going to be neutral. So when they come in contact, what's going to happen is that because these electrons are like charges, they repel. So that means that they're going to repel, and some of them are going to jump ship and come over to this neutral object. Let's say 2 electrons come over. So that means this one and this one come over. That leaves this previously charged object with a few less electrons than it had before. It had 11 before, I've lost 2, so that means I should have 9. My 5 protons don't change. One more time, protons are massive, they're in the nucleus of the atom, they're not going to move from one material to another material, it's only the electrons that change. So now, this object had 2 protons and 2 electrons, so it was neutral. Now it has 2 protons and 4 electrons, meaning it has a charge of -2. And this object still has 5 protons, because that doesn't change, but hopefully 1, 2, 3, 4, 5, 6, 7, 8, 9. I've gotten the number of electrons right at 9, which means it's -4. It's not as negative as it was before, because by coming in contact with the other material, it's shared some of its charge. It started out as -6, having shared 2 to this neutral object, now it's -4, and the neutral object is -2. So that's how you charge by contact with a negative object. It's a little different with a positive object and worth going through. So with a positive object, I'm just going to erase some of this so that we have more space to work here. What we're assuming is that the initial object has a deficit of electrons. So here's our object. So I have 5 protons and only 2 electrons, or +5 and -2, or a net charge of +3. So this is my positive object. And it's going to come in contact with the neutral object, 2 protons and 2 electrons. And what's a little counterintuitive here is we're thinking of this object as sharing its charge with this object, but since the protons can't move, it's not like these protons can jump over onto this neutral object. So it can't share its charge directly. So what happens when these things come in contact with each other is that this electron, for example, sees the excess positive charge over here, or the deficit of electrons, and he wants to jump ship and go over here because he's attracted to that positive charge. What that means then is that this object loses one of its electrons. So the charge is actually transferred from the neutral object to the positive object. And it's left as a positive object. Alternatively, this object that was positive ends up with 1 more electron than it had before. It's still positive, but it's not as positive as it was before. So with a positive object, to share its charge, it actually accepts electrons from the neutral object, and that way this +3 that it had originally can be shared between the two objects in the final situation. So, charging by contact, we share charge. If it's excess negatives, then what is sort of simple happens, where the extra electrons jump over to the neutral object. But if it's positive, because it can't share those protons can't move, what actually happens is a negative charge from the neutral object actually moves to the positive object, leaving them both positive.